Sorry. Sorry, I forgot to record. Okay, just record the class. Okay, until this slide, any questions? No, just continue. Kalisha?
Doctor, this step and method we need to include in the group assignment, ya, Doctor?
Yeah, good. So for the energy audit, that's the step, okay? This all about the step for the energy audit. This is the process. So you must put on your group assignment. So where to the schedule one to have the kick-off meeting, on-site survey. So put the evidence for the kick-off meeting in your report later on-site survey. So what's kind of the on-site survey that you have done? Put on your report or presentation later on for the group assignment and individual assignment, etc. Also kan, yang tu. Okay. This one also, this one. Data collection. So desktop data collection, field data collection. We go to the data collection, okay. The next step, the number what? Number 3. Data collection after on-site survey. So data collection for the process diagram, the picture one, okay. If you go to the SME factory, so the process diagram must be there. Take the picture, or you can ask the factory owner to have one as a copy for the report later on. So energy bill, historical data, at least you get 2 years or 1 year data before, at least 1 year, and the best to get 2 years, because when you get 1 year and another year to be confirmation for this kind of the historical data. Lighting drawing, air conditioning system drawing, so all about drawing for this lighting and system, air conditioning system, design manual, load control system, and automation system over there. So during your visit, please visit to the we call it to the control room to get if that building have the automation system. So get the information from there as well. So you can understand the process easily. For example, a building management system. Inside the building management system, they have lighting system, electrical system, thermal system, for example, cooling system. So with the graphic one, that's the easy way to understand the operation in the fast track understanding to that kind of the operation system in the building or factory. Field data collection, okay, completing the missing data which the auditor could not find during the desktop collection process. So from there, if you can find the data from the desktop data collection to get the field data, so must be kind of the measurement parts to the statistical system, to the most energy user inside the building or in the factory. Verification the accuracy desktop data. Okay, for example, we measure the incoming of the electricity. Okay, and then after that we convert to, for example, we measure for the 2 weeks and we convert to the monthly and can be converted to the yearly, and we compare to the actual bill. So if there is no huge difference from the billing system, and then we just confirm that the verification for the desktop data is true, and our measurement is in the correct measurement way. Okay, understanding close the building operations, make the observation for the energy waste and building maintenance status. So check the operation and building maintenance, energy waste, so during the data collection. Carry out load profiling and load opportuning. This one, load profiling. So from the load that we measure, maybe from the power meter, or they use their own power meter, digital power meter installed in the subsystem over there. So we just verify either their DPM or sub meter is in a good condition or not, and if okay, we can only use their data. For example, we just put the measurement meter together with DPN, and we compare. If there is no huge relative difference to this kind of the DPN, and then we can use the DPN data to do the load profiling and to have the load optioning after that. Carry out necessary field measurement requirement, cross-check of the load demand data. So check the deviation. I did mention about I just mentioned about the deviation, the comparison, and to use the equipment data survey and use loads estimate by logging a second method, and to ensure accuracy of the assumption. If from the bill of the TMB is about 100 kilowatt hour a month, and from our measuring data, we got about 95 kilowatt hour, then it's okay lah, plus minus 5% or less, plus minus 5% is okay. Okay, energy record, monthly bills, logbook, daily. This one record energy equipment. The equipment that we use: electrical measurement, power logger, harmonic power meter, data logger, illumination lux. For example, here this is the power meter. This one now, I said just now 40K the price. And harmonic, data logger, lux measuring. Solder equipment. This one is for the lux, power meter, power measurement. This one we use for the one-off to measure the power. This one logger, okay, logger to measure within the time frame. So we set, for example, 1 week or 2 weeks, we measure this one by using this power meter. But this one is the one-off reading from the meter to know what's the current power for the certain equipment. Combustion analyzer, CO2. Okay, this one we put on the boiler one to get the combustion status for the boiler, for example. Leak detection, lux meter again, infrared. Okay. So for the mechanical part, flow meter. Okay, this one is the flow meter, ultrasonic flow meter to measure the water flow inside the piping, set air velocity to get the velocity of air inside the air handling using for the fan, for the air blower. Okay, gas flow rate, small air velocity in a room, this one, to get the velocity of air inside the room. So if you want to measure the velocity of the air from the AHU coming to your room, for example in the office, so from the diffuser over there, we can measure the velocity of the air in the room. The purpose of that is to ensure that the flow of the air inside the building in the efficient way and have the kind of the balancing from the main supply to the end user. So if we get the same or very close value for the air velocity from the supply air, from for example from the AHU to the end user, that one is the efficient way of the air supply by the system. All those meter gauge, okay, tachometer, can find. This one we can use inside the room. Ada yang beli tak? Saya suruh beli hari tu. Do you buy this one for the energy audit later on? For your own use? Ada?
Tak, tak beli doktor. Tak sampai
Beli
lagi.
dulu. Oh, tak sampai lama betul.
Sampai.
What's the price for this one? RM16 eh? So this one we can have the humidity and the temperature for the room. And the other parts is the CO2. CO2. The content of the CO2 inside the room. So if you have the CO2 meter, then just measure the CO2. Why CO2 is important? So we must know the balance of the portions of the CO2 and the oxygen. If that is the content of the CO2 very high inside the room, and that's the effect from the effect to the consumer or to the people inside the room, okay, which is they don't get enough oxygen, and then that must um, have a proper procedure for the operation of the cooling system inside the building. So the auditor will suggest what's the portion of the air intake from the AHU air handling unit to open for the watts percentage, so they can balance back the supply of the fresh air. For example, to get the enough oxygen or balance the CO2 inside the room. And of course, balance the temperature and the humidity. And humidity is also important because when in the dry condition, okay, that these environments or will affect the human activity as well. Okay, infrared, all these things. Okay, energy equipment from to put the energy meter on the main switchboard, main riser, DB. So all this one we measure the status of the power. Okay, for example here The auditor use the meter here. Okay, this one is the condition in MSB, main circuit board, main circuit board. So this one is the 5 amp from the CT, convert from the 11 okay, from the 11 kV. So we get the about the 1000 amp, for example. So from the CT one, they can measure in front of the board to get the profile of the electricity used in the building. So the assistant, technical assistant here, wear the proper clothes, okay, for the safety. This glove. All right. For the mechanical one, for example, air conditioning chiller pump, so they use these portables flow meter. Why? To get the flow meter, because from here the data we can use to calculate the efficiency of these parts of the chiller plant later on in the analysis part. So for motorized, motor and drive, multiple power analyzer, tachometer, strobo tachometer is the fan one, okay, to measure the flow from the fan of the motor. Illumination, lux meter, flow steam, so ultrasonic steam trap, ultrasonic flow meter, so combustion, thermometer, humidity, infrared temperature, humidity. This one is the pressure meter, temperature meter. Auxiliary equipment, multi-channel data logger, digital power, digital camera, and a notebook. Others equipment, the auditor must also take the picture. So must have the digital camera. So when come to the data analysis, for example here, we get the data for the chiller plant. So annual consumption, we come out for the annual consumption. Okay, basically auditor measure this chiller plant consumption for at least 1 week. 1 week. 1 week. This is a standard energy audit procedure by Energy Commission, at least 1 week for the commercial building. So they get the data for 1 week, come up with the 1 month and multiply with 12 to get the annual consumption. So for the ASU, they come up with the annual consumption. This one is the assumption for the annual consumption, not the record one for the 1 year, for the whole 1 year. This one is 1 week, they convert to 1 month, and they convert to 1 year. So the auditor come out with the annual consumptions. Okay, this one is the assumption one. Assumption one. Then for the overall, this total, they compare to the TMB bill. TMB bill for 1 month, monthly, and yearly. Okay, so lighting, others, mechanical ventilation, and this one, we call it as load opportuning. Load opportuning. So what's the percentage for the chiller plant? What's the percentage for the pumping system, ventilation system, lighting system, AHU system. So load opportunity is important to present in the energy audit report later on. So from here, we can know what's the biggest consumer in this building. For example, here is chiller plant consists of 48.4% the energy usage from the total energy usage every year. So what's to focus for the ECM? So auditor know this 48.4 is very huge. And plus with the components of the cooling system here, AHU, air handling unit, and FCU also from the cooling system. Maybe auditor will come up with the general load breakdown. For example, lighting and cooling system or others. The rest is others. Others and cooling system. So the cooling system, this one, come up with this one, and if pump is contribute to the cooling system and then plus pump. So what's the percentage for the cooling system here? If the auditor want to show the breakdown, the general breakdown from this lighting and cooling system and the others. So what's the percentage? 4.8 plus this one. Berapa dapat? What's the percentage? Someone help me to calculate. Tak dapat. Guys, are you with me?
64.4.
Sorry, Kalisa.
64.4.
64.4%. So we know that the cooling system inside the building, okay, for this building generally consists of 64.4% use very big energy for the building, 64.4. So the solution must focus on this one rather than this other system. So if you said that, oh, the first thing I want to tackle on the lighting. Lighting just represent 13.9% or close to 14%. Okay, so but the different angles, if you know this load opportunity and the auditor, the experienced auditor, okay, said that the first thing to tackle is the cooling system because cooling system consumes 64.4% rather than we focus on the other system, which is the small part. And if you put the effort to reduce the small part and you get the result, not the big impact for the result later on. So the program must tackle the biggest consumer or the system in the in this load opportunity. You get it? No.
Yes, doctor.
Okay, load data profile. This one is data profile. So data analysis, losses and process equipment. So 1 week load profile, for example, this one, okay, we come out with the load profile analysis. So from here, we get this one, the power consumption for this one, okay, 7 days, 1 week. So what's the analysis that we can do for this kind of the profile? So auditor must come up with the idea. For example here, okay, that's the 2 days this building used in the high consumption operation, and that's the opportunity to lower down this one. Okay, why not they just operate on the normal operation here? So this one we consider losses because in the many days that this building operate in the normal condition, and for 2 days they operate in the abnormal condition, and we can call it as the losses. From here, what's kind of the ECM you must put for this report, energy audit report? Maybe you can put the awareness, okay, awareness to follow the policy, or to get some effort for the equipment, okay, BMS, for example, to consider maximum demand, um, notification if certain value achieved during daily operation. For example here, if the maximum demand achieved or more than 420 kilowatt, and that's the certain notification received by the consumer inside the building, or the owner of the building can have a notification for this kind of abnormal reading. Okay, so after that they can take the action to reduce the consumption. Okay, that's the idea. So here, to find the average for the base load, this one we call it as base load. This is the peak normal consumption. So we know that this building started the operation on 8 p.m., 8 a.m. and closed the premise at 5:30 p.m. Okay, so after that, here, why this condition happen? So what's the activity here? Activities, what are the activities here? So that's the opportunity to reduce this one, the activity during the night activity. Okay, to get this kind of the sustain value to the 50 kilowatt only, instead of this one close to 100. So the opportunity to get it stabilize this data or this profile, okay, after 7, so to get only 50k, so the another 50 kilowatt can be saved if this idea or ECM will be taken by the consumer. So as auditor, you must know on how to analyze this one. So that's why in the first, what you call it, the first on-site survey, auditor must understand the operations of the building. See what's the activity, what's the human activity over there. So you can come up with your own idea on how to solve this kind of the activity, or to suggest another solution for this activity. Okay. ECM. So to prepare the ECM, started from the no cost, low cost, and high cost. This one. So after that, auditor must come up with the no cost, low cost, and high cost. Okay. Okay, what now? What's going to do is to get the sample of the data from the Telegram. I will share the data of the energy energy profile from the smart meter. Okay, this one for your practice to get to come up with a good analysis for your individual assignment. Dapat tak? Do you get it from the telegram?
Tak ada Doktor.
Huh? Can you get it from the telegram?
Ada. Tak ada Doktor.
Tak ada.
Not get Telegram, Doctor.
And now?
Dah ada dah.
Okay, this one is sample Hun data for student. So open the please open the Excel data. Okay, the first thing I want you to have the idea on the correlation one. Okay, for example, to get know the process and the energy consumption correlation, the relationship through the significant analysis of the R square value. R square value. So open the Excel. Click the bottom one, the data correlation. Dapat tak?
Dapat Doktor.
Nampak Doktor.
Okay, this one the data from the simulation manufacturing. Manufacturing, for example, they have the production unit. This one is for the end product, the production. Here, the production, and this one is raw materials. As we know, this one is the process, okay? Process and raw material and the product. And the bill of the energy here. So we want to classify or to check either what by comparing this raw material and the product unit, what's the correlation value? Which one is very close correlate to the contribute to the bill of the electricity in this factory? So how to do that? First, we are going to get the kilowatt hour and the unit, okay, unit of production. This one is for the production. Go to scatter one. unit of production versus energy consumption, right? So we get the data for the energy consumption from the bill of electricity, and the unit of production we get from the operation management. So we come up with the correlation. Okay, so how to do that? Right click to find add the trend line. Okay, this one is linear. Click the arc square. So now the arc square value, guys, everyone okay? I hope you can follow this step. Okay tak ni korang ni?
Okay, Doctor.
Okay. Do you get the same value R square here? The unit of production versus energy consumption. Okay, now. Okay, focus now. Because at the end of this class, you must submit this one to me. Huh?
Boleh ulang lagi tak?
Okay. So for this one, we want to get we want to know the correlation, correlation, and we get the data from the bill, okay, of electricity here. So this one is the unit of kilowatt from January to December. So for the production, this one is the production data in unit. So how many units? Those is about 3,000, etc. So this one in unit. So in order to produce the end product, so this factory have their own raw material. So they use the kg, kilogram as the raw materials for them. So we want to know which these variables, for example, a production unit or raw material in kg, that very close to the contributes to the bill of electricity. So just select these both of data. For example, we do it separately. Okay, kilowatt hour data and unit product. Okay, draw the scatter one. Or you want to clean the graph, use this one. Use layout 10. Layout 10. Okay. So put the title for axis. Production in unit. And this one is energy consumption, right? So from here, how to define the correlation? Right click and add trend line. Add trend line. Okay. So here we got the trend line here for the linear one. And then from the format trend line, just click at the bottom of the this trend line option. Click display equation and display R square, or you can only display the R square to define the correlation. Okay, this value of the R square more close to 1 represent the significance of the correlation between the variables to the energy consumption. Okay, do it the same procedure or method to the raw material. Scatter, right? Scatter 1. Use layout number 10. Draw in kg. Energy consumption. Okay, right click to add the trend line data. Okay, which one the variables close to that contribute to the electricity consumption by comparing these two variables? Which one? Which the significant R square? So this the value R square, if the value of the R square close to 1, which means that is the high significant or correlation to the between two variables or between the parameter. So which one?
Raw material.
Production unit. Production unit. Raw material is only 0.0139. Okay, the production, the R square for the production is higher compared to the raw one, the raw material. Okay, so the production unit close, very close, significant that one of the variables contributes to the energy process in the factory. So we can also consider this production units, the value, as the factor. Factor, remember when we design in the chapter 3, when we want to produce the EEI or BEI, energy efficiency index, okay, equal to energy consumption over factor related to the energy. Okay, so for this one, we have the energy consumption in kilowatt here. Okay, so get the 1 year data. For example, we have the total one here. So what's the EI for this factory for 2020?
15 156,057.
over this one, right?
Yes.
So we get the value for the EI is 4.16 here. So what's the value for the EI in 2019? Ya, Azam, ni Azim.
Macam mana buat yang R square tu? Terlepas lah.
Allah. Square, okay. We do this one. Square, select this one. Sekarang ni dah ada graph Scatter. Okay, right click, add trend line. To find the option, tick display R square.
Oh, okay. Okay. Thank you, Doctor.
All right, welcome. So from here also, we can have the baseline, okay, the data for the for this one, okay. This one is energy data for 2019. Get the right axis name, energy consumption, kilowatt hour. This one, data for 2009. Okay. So you can make the comparison data for the 2020 by select and add the data here. 20. Okay, now you get the data here, right? And this one is the comparison between the energy consumption data from the 2019, 2020, from January to December. This one is a 12-month data. And also comparisons for this one. And to normalize this factor and to get the right, we can also move the 2020 factor to the 2019 factor. Okay, now that's the baseline adjustment for the factor, and we get to know that the performance for the 2020 for the factory is better than 2019. By look at this, what we call it, the bar chart here, and we know the performance, we can compare the performance of both years for this energy consumption. For example, January 2019 is higher compared to 2020. Okay. But for the February, the year of 2020 is higher compared to 2019. And we must also refer to the consumption, production, etc. to verify all this data. So the activity, the production one. Okay, get this graph also in your Excel. Okay, here is the home data. From 7 days. So imagine that you have this one. This one is the desktop data from 2019. Okay, so make this data available. For example, to get this one first, move to the data example from the from home. So this one, month. So get the graph for the 2020 as well. Right click, select data, add data series 2020. This one. And we have a bit data from the 2021. Okay, here. So just put the performance, trace the performance for 2021. This one. At 2021. Here. Okay. The gray one is represent 2021. Or you can select another colors. This one. Or this one. This one. Okay. Okay, now we have produced the desktop data from the billing of electricity bill. Okay, so the performance of the electricity consumption, energy consumption here is kilowatt hour, not kilowatt hour. At least you can produce this one. Okay. And remember the process, the flow of the energy audit. We get the desktop data here. Okay. Okay, for EI, for this home, EI, the commercial area or commercial building, with the area. So to create the EI, so factor related is the area of the building. So for this home, the square feet is 1,700 and convert to m square, meter square, and get the value for the energy consumption for the 2019 and 2020, and we can compare the performance EI, energy efficiency index for both years, for the 2 years. Get the total consumption here. For 19. So the consumption over the area. Consumption for 2020 over area. Okay, clean the data by using this number. Can use the single number here. The performance of the EI is not in good condition because when we compare to the 2019, there is the increments of the EI, so which is EI not improved because of the consumption is higher compared to 2019, right? We can see on March, there's the large energy consumption. This one is a COVID ni, masa MCO. During the MCO, okay, that's the data compare during the MCO and without the MCO one. So that one is the desktop. From the desktop data, from the billing, from the bill, so we get this analysis. Okay, so this one is from the meter. The meter measure energy consumption, the kilowatt hour from 12 to 11. Okay, every day. This one is 24 hours data. So from this measuring meter, you can put the graph for this one. For example, okay. So we have 7 days graph for this home. Edit to add name. Don't forget to put the axis name, energy consumption, kilowatt hour, and time here. Okay, from here we can make the analysis for the consumption. Okay, look at here from 12 a.m. to the 11. So this is the profile for the electricity for this home. And if this electricity in 2020, and we know that that's the consumption during the peak hours here from the 8 a.m. to the 10 a.m. This the area for the peak, and here the area for the peak off peak. You get this graph, class, guys?
Tak dapat, Doktor.
Allah, tak dapat pula.
Tak dapat.
Okay, for your information, tomorrow I have to go to one of the program by MBHTJ so that I can make synchronous class. But I will adjust my schedule so that this class, tomorrow class, will be replaced in other time or another day. I think is it possible for us to make to do our replacement class on Saturday at 10 a.m. Is it possible?
Yes, Doctor.
So I will explain more about this kind of graph, etc. So we do some exercise on that day. Boleh?
Boleh, Doktor.
Boleh, Doktor.
Okay. If okay, then we
Okay,
stop
Doctor.
here for today, and we continue on this weekend, Saturday at 10 a.m. Inshallah. Okay, so I will teach you on how to analyze these data in detail later on, inshallah. Okay, can?
Can, Doctor.
Okay, thank you. I think that's all for today.
Thank you, Doktor.
Okay, thank you.
Doctor.
Thank you.
Thank
See you.
Doctor.
Doktor.
See you in the next class.
Thank you,
Thank you.
Doctor.
Thank you.
Welcome.
Thank you, Doctor.
Bye bye.
Bye.